I'm here with my topic, that is coordination compound, which is from the chapter number 9, which is also known as coordination compound. So let's start with the introduction of the coordination compound. In the study of the transition metals, we have learned that one of the important character is to take part in the formation of the complex compounds. These are known as coordination complexes or coordination entities. According to IUPAC system, as the name suggested, the ions of these elements are involved in the coordination bond resulting in the complex compounds. In the formation of these compounds, normal valency rule are not obeyed. That is why these are called complexes. In addition to the transition metals and their ions, a few other metals are involved in the coordination complexes. For example, magnesium, an element present in group 2, which is known as alkali earth metal. I talked about magnesium, which is from group 2 and which are known as alkaline earth metal, is present in a very important complex chlorophyll. These compounds are widely disturbed in the mineral plants and animals and play very important roles. In fact, these are different in their structure from the normal covalent and ionic compounds. Now I am here with my next topic, that is coordination compound and their general introduction. Let me give you definition for the coordination compounds, like a molecular compound resulting from the combination of two or more stable molecular compounds and retains its identity in the solid state as well as in the solution, and its properties are totally different from the constituents present. In order to understand the significance of the coordination compounds, let us mix the aqueous solution of the furious cyanide and potassium cyanide in the china dish or beaker and evaporate it to the dryness. Like here we will take this one, then cyanide, this is Cn, this is the aqueous solution, this is furious cyanide, and the next for this only the same. Let me tell you again. This one is Fe, then this is aqueous solution of aqueous solution of furious cyanide, then this is the aqueous solution, and next is with plus 4K Cn, this is potassium cyanide, this is also aqueous solution, and we will evaporate it and it will become K4. Fe means here furious, here cyanide, Cn6. Then by this is the potassium furocyanide we prepared, and the result left is well known compound called potassium furocyanide, although it has the different name in the coordination chemistry when dissolved in water. Like let me show you. It will make K, first of all K4, then here Fe means furious, then here cyanide, this is known as potassium furocyanide, this is all potassium furocyanide 6, and here aqueous solution, then it will become 4K positive, this is also aqueous solution, and next it is Fe, same, the furious cyanide, this is also with 4 negative, this is also aqueous solution. By this we got to know about this, and the species which is enclosed in square bracket is known as complex ion. It has been found to be very stable and does not give any test for the Fe2 positive or Cn negative ions, so that the potassium furocyanide is used to test the presence of the Fe3 positive ion in a mixture. By this I am finished with my topic. Thank you.
Hello everyone, myself Mansi. As we all know that we are done with our last unit, which was about D and F block elements. So now we have started our new unit, which is about coordination compounds. So if we'll talk about coordination compounds, so these are the compounds which retain their identity even in the solution state. Usually, this chapter has been divided into three parts: one, terminology; second, nomenclature or isomerism; and last, we have bonding. So, today we'll talk about terminology. So, here are the sum of terms which I'm going to explain. So, first, we have coordination entity. It contains central atom ion surrounded by the fixed number of ions or molecules. Second, we have ligands. Ligands are the ions or molecules which donate their lone pair to central atom ion. These may be positive, negative, or neutral. After this, we have coordination number. Coordination number shows the number of ligands bonded to metal. Fourth, we have oxidation number. Oxidation number shows the charge carried by the central atom ion if all ligands are removed. Fifth, we have charge on complex ion. It is the algebraic sum of the charges of central metal atom ion and ligands attached with it. This can be positive or negative. And last, we have carbonyl compounds. These are the compounds of transition elements. They may be pi bonded or alpha bonded. The bonding creates a synergic effect which strengthens the bond. So this was all about today's topic. Hope so you understood all the terms. Thank you so much.
Time. As we all know that we have finished our chapter 8, that is D and F block element, and we have started our new chapter, that is coordination and compound. So without wasting your much time, let us start with today's topic, that is coordination compound. What do you mean by coordination compound? Coordination compound, these are those compound which retain their identity even in a solution state. Okay, there will be no change in their identity. So coordination compound, this chapter is divided into three parts, that is your first terminology, second is your nomenclature and isomerism, third is your bonding. So today we will discuss about terminology. So here are some terms. First is your coordination entity, second is your ligands, third coordination number, fourth oxidation number, fifth charge on convex ion, fifth, sixth is your carbonyl compound. So let us start first, that is our coordination entity. So what do you mean by this? It contains central atom surrounded by the fixed number of ion or molecules. Here as you can see that central atom I have marked with blue, it is surrounded by the fixed number of ions or molecules. Second is your ligands. Ligands, what are ligands? The molecules or ion attached to the central metal atom or ion are known as ligands. Okay, these are the ion or molecules which donate their lone pair to central metal ion or atom. These may be positive, it can be positive or negative. So third is our coordination number. Now what do you mean by coordination number? The total number of ligands attached to the central metal ion is called coordination number. In simple way, it shows the number of ligand bonded to the metal. Okay, for example, in linear we can see that in between red dot is, suppose red color dot is your any atom which is bounded by any ion, any atom is known as your coordination number. Fourth is your oxidation number. What is your oxidation number? It shows the charge carried by the central metal ion and ligands attached with it. It can be positive or negative. For example, we are taking an example of CuCN4 3 negative. Here oxidation number is positive and we can write, it can be written as Cu. Copper. Fifth is your carbonyl compound. Now what do you mean by carbonyl compound? These are those compound of transition element. Okay, these may be, it includes sigma bond and pi bond or both. With this I hope you understood this topic.
Very warm good morning to one and all present over here. I am Asta from Devi Public School, Manali. Today I am before you to share my views regarding chapter 9, that is coordination compounds. So what are coordination compounds? These are those compounds whose two electrons are shared by only and only central atom. So here you can see an example. M is the central atom and its two electrons are shared by its ligand. Now what is ligand? It is that element which attack only and only on the central atom. coordination compounds, that is compounds of transition elements. So earlier in class plus 1 we had studied about NaCl, MgCl2, but now in this chapter we'll study compounds like copper bracket NH3 bracket close 6 and outside square brackets. Remember one thing, that coordination compounds are always enclosed in a closed bracket. So here we'll study compounds like titanium, vanadium, chromium, iron, cobalt, nickel, copper. Scandium, manganese and zinc will not study here because scandium have only one unpaired electron, manganese is incompletely filled and zinc is completely filled. So this chapter is divided into 3 parts. First is introduction, second is isomerism in coordination compound, third is bonding in coordination compounds. So in introduction part we'll study important terms, then basic theory of coordination compounds, Warner's theory, nomenclature, steps and rules to give names to the coordination compounds. And in second part we'll study about structural and stereomerism. It is a type of isomerism in coordination compound. In structural isomerism we'll study about ionization, hydrated, linkage, coordination. And in stereomerism we will study about geometrical and optical. Geometrical is of two types, cis and trans, and it will give two shapes, square and octahedral. And second one is optical, and it is dextro-rotatory and levo-rotatory. So third, which is very important part, it is bonding in coordination compound. So in this we'll study about valence bond theory, its postulates, MX4 and MX6 structures, limitations of valence bond theory. And after that we'll study another theory, that is crystal field theory, its postulates, important compounds with example, reasoning type question, and third but not the least we'll study about bonding in carboxyl compounds. Metal, that is, say one metal is attached to the carboxyl, such type of compound. So I hope that overview map of this chapter is well clear to you. Thank you and have a nice day.